Okay, welcome to the last of the 1108 labs. In this lab, we're going to be doing some geometric optics, and specifically we'll be looking at lenses for a little bit. How do lenses work? Lenses are basically refraction. That's the thing we covered last week with the glass of water. Last week, the refraction we were talking about was light rays bouncing off flat, smooth surfaces. When you get to lenses, the same physics happens, except instead of having a flat, smooth surface, you have deliberately, very carefully curved surfaces. Surfaces that are built so that incoming light rays are bent according to the refraction we studied last week, but because they hit this smoothly curved surface at different angles, they get refracted by different amounts. And the idea is that you can take all the light rays that come off of one point on an object and gather them back together to be at one point in a plane. And then if you look at that point, you see all the light rays that came off the object, and you thus have a much brighter picture of it that you can also magnify. Lenses have been around for a very long time. Galileo had a telescope with which he famously saw the moons of Jupiter. Nowadays, lens design is a big engineering thing. People actually have won Academy Awards for designing custom lenses. It's an amazing fact, but a physicist has an Oscar on his shelf. How about that? Okay, in your kit, or rather, we have sent you a list of some lenses to purchase. I got these from Office Depot. Yours are doubtless similar. The first thing to do is to measure the focal length of these lenses. The focal length is just a number that tells you how strong a lens is. A lens with a large focal length is a weaker lens. A lens with a small focal length is a very strong, very focusy kind of lens. You can measure the focal length of a lens in a very simple way. Here's a lens. This is just a cheap little thing. And what I'm going to do is use it to make an image of the light up in the ceiling. Here in the studio, we have a lot of lights illuminating us. The one in the ceiling is particularly nice. If I hold the lens off a piece of paper and move it up and down, at one point along here, suddenly a little picture of the light in the ceiling jumps into focus. You move it out and it's just a blur. Move it down, there it's in focus. Keep going and it blurs out again. But at this one point, the light in the ceiling is in perfect focus. And if you look closely, you can see that it's an actual pretty good image of the light in the ceiling. This works with all kinds of lenses. Here's a big one. If I move that around, I see nothing, I see nothing, I see nothing. Suddenly, boom, there's a really nice big image of the light in the ceiling. You can image almost any light source like this. It really is kind of fun. And this thing has another little lens up in the corner. I can do the same thing with that. I get the light in the ceiling right about there. So what I want you to do is image whatever light source you're using right now, and to find the focal length from that. The focal length is just the distance from your piece of paper to the lens when you have light in the ceiling in focus. So Now I've got the ceiling light in focus, and the distance from the paper to the lens is about 2.5 inches. So this one has a focal length of 2.5 inches. This big one has a longer focal length. It's a weaker lens. You don't get a focus till you're way up here. And measuring that, that's about 7.5 inches. The little bubble one in the corner focuses here. Measuring that distance, I get 2.5 inches. So I have 2.5 for the bubble lens, 4 for this lens, and 7.5 inches for the big lens. Once you know the focal length, you can start to predict things. Another thing you can do with lenses is build a very simple telescope. Telescope is just a combination of basically 2 lenses. You have one out front with a long focal length, and then there's one behind with a short focal length. So if I take this big lens with the 7.5 inch focal length, and I put behind it this little lens with the 2.5 inch focal length, I should be making a little telescope. I look through the one with the higher magnification, the smaller focal length, and this actually does work. If I move things around enough, this one happens to be sharp right about here. By the way, Galileo's telescope was just about this crude. It's kind of amazing that he did as much as he did with it, but it was just about like this. And now I can see things hanging on the wall over there. They're fairly clear. They're actually magnified quite a bit. We take that away, see that they're quite a bit larger when they're in focus. The magnification should be about the ratio of the focal lengths. This is 7 on one, 2.5 on the other. That gives me a magnification of 2.8 or so. And it did. It looked about 2.8 times as large. What I want you to do for this lab is to, first off, find the focal lengths of the lenses you have, and then assemble them into a telescope, calculate what kind of magnification you expect to see, and see if that looks roughly compatible with what you're getting. It should work. I don't know, some people have problems seeing these things. But anyway, this is the last lab for 1108. It's been a lot of fun, and good luck. Bye.